Hi everyone! In this video, we're going to learn how we can work with arrays and functions. In our last video, we had a main function that was really long. We solved a bunch of problems related to arrays and loops. Now we want to learn about how we can solve those problems by implementing our looping algorithm inside of a function that we can then call whenever we need it. For example, displaying the contents of an array. That is a really common problem that we need to solve all the time. So let's put it in a function so that we can reuse it over and over again whenever we want to see some insight as to what are the contents of our arrays. All right, beginning with our warm-up task, let's go ahead and open a file called arrayfunctionfun.cpp, and let's just code up an empty main function. We can pass arrays into functions as arguments, just like we would pass in any other data type into a function. One thing to note though, by default, arrays are passed by reference. That means that any changes you make in a function to an array parameter will update memory for the array argument in the calling code. So let's take a look at an example of doing this. Let's go ahead and code up another integer array called numbers. And go ahead and just make up a bunch of different numbers again. Let's first call a function that prints the array so we can show before and after of an array. And then in between a call to print the array and then another call to print the array, we're going to call a function that's going to modify the array elements. That way we can see that the changes to the array do persist. So let's write our prototype first. This will be a display array function, and it'll accept an integer array, and it should also accept a size. So while we're at it, let's go ahead and declare a constant integer for the number size. Mine has 2, 4, 6, 7 elements in it. The reason why I want to pass in the size instead of just using this constant integer up here in display array is because I want this display array function to be reusable. Let's say that I later declare another array of integers and maybe it has 10 numbers in it. If I hard code display array to use size as part of its Boolean condition in its loop, then I won't be able to reuse display array to print out my 10 element array as I would like to. So I'm just going to print out each element in my array separated by a space. That way they're all on the same line, which will make my output much more short. And then after my for loop, then I'll just print out a single new line character to advance the cursor to the next line to prepare for printing the next output. So I'm going to pass numbers in as the argument to my display array function. I'm also going to pass in size in all caps, that's our constant, in order to denote the number of elements in my array numbers that should be printed. Now we've got a prototype for display array. It's got an integer array as the first argument and an integer array for storing the second argument. Down in the definition, I've got a parameter called ARR, just a general term short for array, and a parameter called size. Note that this is all lowercase, a different size than my all uppercase one. And they're going to store those incoming arguments. Now, ARR is a reference to the numbers array. One of the main points I want to drive home in this video is arrays are passed by reference by default. We don't add any ampersands, we don't need to. The fact that they're an array, as denoted by our hard brackets, makes them pass by reference. Arrays are large. Our small one here, 7 elements, maybe not so much, but they could be 10,000 elements large. You definitely do not want to do any copying, as in pass by value, when you pass a 10,000 element array into a function. All right, let's check this out. Looks like we've got some nice output here for the contents of our array. Okay, now what we want to do is call a function that modifies the array. And then we're going to call our display array function in order to display the array again. So let's have this function multiply each number by 2. We'll pass in numbers and size, which means our prototype is going to look just like display array, but this time it's just going to be called something different. In fact, I'm going to be a lazy programmer, and I'm just going to copy and paste the entire display array function because I need that standard array processing for loop. No cout statements in multiply by 2. We've already solved that with our display array function. What we're going to do instead is multiply each element by 2 and overwrite that element with that product. And I print out the array before doubling it, and then I print out the array after doubling it, and I do see that each element of the array is doubled. So there's your evidence to support that arrays are passed by reference. This isn't a copy of the numbers array that we're multiplying each element by 2 in and overwriting. This is the actual numbers location in memory. All right. Now, one big takeaway point that can help you when working with arrays and functions is you can use the const keyword in order to make a parameter that's an array immutable, meaning it can't be changed. For example, display array. Display array should never modify the contents of the array. It should only access them in terms of read-only. So we could put const on our parameter declaration for ARR in display array, and then if we ever tried to do something in this code, let's say add 1 to each item, I'm going to get an error. It says line 38, which is the one where I just added that code. Error, assignment of read-only location. So that's something you can do to help yourself not modify an array accidentally. Go ahead and just slap a const on that parameter and you won't be able to change it. The compiler will not let you get away with it. All right. At the end of the lesson notes, I have some commentary on returning an array. So we've seen how we can send an array as input to a function. It's passed by reference. But how can we return an array as an output from a function? Well, the short story is you can't. Recall that local variables are deallocated when a function exits. So since arrays are passed by reference, if you were to allocate an array in a function and then return a reference to that array, that memory would be deallocated. Arrays are not copied. They are passed by reference. That's why you can't return an array from a function. That's the short story. That's the 121 version of the story. You actually can return arrays using advanced techniques beyond what's covered in this class. There's a topic called dynamic memory, which allows you to allocate memory in a different region of your program memory that is not deallocated when a function exits. In order to learn about dynamic memory, you'll have to learn about pointers, and both pointers and dynamic memory are not 121 topics, they're 122 topics. So in summary, you can pass arrays into functions. They are passed by reference, but you cannot return an array from a function because arrays are passed by reference. So stay tuned for another class, say 122, or just reading on your own if you want to learn about how you technically can return an array using pointers and dynamic memory.